Something massive is approaching Jupiter. Scientists detected it 3 weeks ago. 68 kilometers per second. That's how fast this interstellar object is moving through our solar system right now. And in exactly 21 days, 3IATLAS will reach its closest point to Jupiter, potentially triggering an event that could reshape our understanding of planetary defense forever. Stop. Think about that speed for a second. Our fastest spacecraft barely reached 17 kilometers per second. This thing is moving 4 times faster. The Atlas telescope network in Chile caught it first, but what they saw in the data made no sense. The object's trajectory showed a 7.2% deviation from where gravity alone should have taken it. That's not a measurement error. That's not atmospheric interference. Something else is affecting its path, and Jupiter sits directly in its way. Scientists are concerned because we've never tracked an interstellar object this close to a collision course with a planet in our solar system. The numbers coming from NASA's Jet Propulsion Laboratory paint an unprecedented picture. Current distance from Earth, 0.56 astronomical units. Orbital eccentricity, 0.62. These aren't just statistics. They're warning signs that our models for predicting cosmic collisions might be fundamentally incomplete. Dr. Avi Loeb's team at Harvard noticed it first. The non-gravitational acceleration. The way 3IATLAS speeds up and slows down without any visible reason. Our best telescopes show moderate outgassing from its surface, but here's the problem. That's not enough to explain the movement patterns we're seeing. The Hubble Space Telescope's latest measurements put its nucleus at just 4.2 to 5.6 kilometers across. Too small for the forces it's generating. Too light for the path it's carving through space. Nobody expected what happened next. When the James Webb Space Telescope turned its instruments toward the object last week, the spectroscopic data revealed carbon-rich compounds on its surface. Not unusual for a comet. But the emission patterns? Those changed everything. The gas jets aren't following standard sublimation models. They pulse, they rotate, they shut off completely, then restart hours later in different configurations. That shouldn't be possible. The Minor Planet Center designated it 3IATLAS, the third confirmed interstellar object ever detected passing through our solar system. But unlike its predecessors, Oumuamua and Borisov, this one isn't just passing through. Its current trajectory, updated just yesterday by the Atlas network, shows a path that brings it within Jupiter's gravitational influence zone, not a distant flyby, not a wide miss. We're talking about a close encounter with the largest planet in our solar system. 0.35 astronomical units. That's how close 3IATLAS came to our Sun on October 29th. For perspective, Mercury orbits at 0.39 AU. This object dove deeper into our solar system's gravity well than our innermost planet. And survived. The heat should have torn it apart. The tidal forces should have fragmented its nucleus. But the latest imaging from the Lowell Discovery Telescope shows it intact, accelerating outward, heading straight for Jupiter. Scientists are scrambling to understand what makes this object so resilient. The current brightness measurements fluctuate between magnitude 17.5 and 18.2, visible only through powerful telescopes. Amateur astronomers with 8-inch instruments can barely detect it in the evening sky between 9 and 11 p.m. But professional observatories are watching it constantly now. Every major telescope network on Earth has protocols in place for tracking potentially hazardous objects. None of them were designed for something moving this fast from outside our solar system. The math is unforgiving. At its current velocity, 3IATLAS carries kinetic energy equivalent to thousands of nuclear warheads. If it strikes Jupiter directly, the impact will release more energy than all of humanity's weapons combined. The Shoemaker-Levy 9 impacts in 1994 left scars on Jupiter visible for months. Those were fragments of a broken comet from within our solar system, moving at a fraction of this speed. This is something else entirely. ESA's spacecraft fleet, Mars Express, ExoMars and JUICE, have all been repositioned to observe the approach. The data they're collecting challenges our fundamental assumptions about how objects behave in space. The non-gravitational acceleration shows a 92% confidence level in the latest measurements. That's not speculation anymore. That's confirmed deviation from known physics. Think about what that means. Every comet we've studied follows predictable patterns. Solar radiation heats the surface. Ice sublimates into gas. The gas creates thrust. We can calculate it down to meters per second. But 3IATLAS breaks those calculations. The James Clerk Maxwell Telescope's spectroscopy shows standard cometary compounds: water, methane, carbon dioxide. Nothing exotic, nothing that should produce these acceleration anomalies. Yet here we are, watching it happen. The implications ripple outward. If our models can't predict the behaviour of a 5-kilometre rock, how can we protect Earth from similar objects? The Planetary Defence Coordination Office has been running simulations non-stop since the discovery. Their preliminary results suggest that an object with these characteristics hitting Earth would bypass most of our theoretical defence strategies. Too fast to deflect, too unpredictable to intercept. But Jupiter might save us by showing us exactly what happens. December 5th, 2025. Mark that date. That's when 3IATLAS makes its closest approach to Jupiter. Current models, the ones that already failed to predict its path accurately, suggest it will pass within Jupiter's Roche limit. That's the distance where tidal forces become stronger than the object's own gravity, where things get torn apart, where solid rock becomes a stream of debris. Unless this object is even stranger than we think, public speculation has exploded across social media. The hashtag 3IATLAS has generated over 4 million posts in the last 72 hours. People are comparing it to science fiction scenarios, alien probes, even deliberate attacks on our solar system. Joe Rogan devoted an entire podcast episode to discussing the possibilities. Elon Musk tweeted cryptically about preparing for visitors. But behind the sensationalism, real scientists are genuinely puzzled. Michio Kaku raised an uncomfortable question during a recent interview. What if the non-gravitational acceleration isn't random? What if there's intention behind it? The scientific community largely dismisses such speculation, but when pressed, they admit they can't explain the observations either. The confidence intervals on their predictions keep widening. The error bars keep growing. The closer 3IATLAS gets to Jupiter, the less certain we become about what will happen. That's not how science usually works. Typically, more data means better predictions. More observations mean refined models. But every new measurement of 3IATLAS adds complexity rather than clarity. The latest update from NASA's Near-Earth Object Database shows trajectory adjustments that shouldn't exist for a dead rock in space. Small changes, fraction of a degree adjustments. But at these speeds and distances, small changes have massive consequences. We need to talk about those consequences. Jupiter's gravity well extends for millions of kilometers. Its 4 largest moons, Io, Europa, Ganymede and Callisto, orbit within what could become an impact zone if 3IATLAS breaks apart. Europa, with its subsurface ocean that might harbour life, sits particularly vulnerable. A high-velocity impact could crack its ice shell, exposing that ocean to space, ending any chance of finding life there, destroying one of our best hopes for understanding biology beyond Earth. The European Space Agency's JUICE mission, currently en route to Jupiter, might arrive to find a completely transformed system. Mission planners are already discussing contingencies. How do you study moons that might be covered in fresh impact debris? How do you navigate through a cloud of high-velocity fragments? These aren't theoretical exercises anymore. These are real decisions being made in control rooms across the world. Current solar elongation, 78 degrees. That means 3IATLAS is positioned far enough from the sun in our sky for optimal observation. Every professional telescope that can see it is watching. The data streams are overwhelming. Terabytes of measurements, images, spectra, all pointing to the same conclusion. Our models are broken, not slightly off, not needing minor adjustments, fundamentally broken. The object that shouldn't exist is heading toward a planet we thought we understood, and we can't predict what happens when they meet. The James Webb Space Telescope has reserved emergency observation time for December 5th. The Hubble Space Telescope will interrupt its schedule. Every major observatory on Earth will point toward Jupiter, because this matters for more than just scientific curiosity. 3IATLAS represents a new category of threat. Interstellar objects moving at extreme velocities with unpredictable behaviors. Earth's current planetary defense systems assume certain things about incoming objects. They come from within our solar system. They follow gravitational paths. They respond predictably to solar radiation. 3IATLAS violates all 3 assumptions. The latest mass estimate puts it at 1.2 times 10 to the 13th kilograms. That's roughly the mass of a small mountain. compressed into a sphere just 5 kilometers across. The density calculations suggest a composition unlike typical comets, too dense for a rubble pile, too light for solid iron, something in between, something we haven't seen before. Pattern interrupt. This is important. Scientists use the term gravity assist to describe how spacecraft steal momentum from planets to accelerate. 3IATLAS will experience the most extreme gravity assist ever observed. If it survives the encounter with Jupiter, it will exit our solar system faster than it entered, potentially carrying information about our solar system's largest planet out into interstellar space, like a messenger we never meant to send. But first, it has to survive Jupiter. The gas giant's magnetosphere extends 26 million kilometers into space. That's 75 times wider than the distance between Earth and the Moon. Any object entering that zone experiences forces we can barely comprehend. Radiation that would kill a human in seconds. Magnetic fields that induce electrical currents in conductive materials. Charged particles moving at relativistic speeds. 3IATLAS is heading into that maelstrom at 68 kilometers per second. The interaction will be violent. The question is whether it will be violent enough to destroy the object completely. Current spectroscopic data from October 2025 shows active regions on its surface, places where volatile compounds are escaping into space. These weak points might be where Jupiter's forces tear it apart, or they might be something else entirely. Controlled venting, deliberate outgassing, patterns that suggest, no, we can't go there yet, not without more data. The scientific method demands skepticism. Extraordinary claims require extraordinary evidence. But when the ordinary explanations fail, when the standard models break, when the numbers don't add up, what then? We're left with questions that challenge not just our understanding of physics, but our assumptions about what moves through the darkness between stars. Time for hard facts. The latest orbital solution from the Minor Planet Center shows a hyperbolic trajectory with an eccentricity of 0.62. For non-astronomers, that number reveals something crucial. This object came from Interstellar, space, and will return there. Our solar system is just a waypoint on a journey that started before our sun formed and will continue long after humanity is gone. We're witnessing a few months of a voyage measured in millions of years. Unless Jupiter changes everything, a direct impact would vaporize 3IATLAS instantly. The energy release would be visible from Earth with amateur telescopes. Jupiter's atmosphere would glow with the heat of impact for weeks. New chemical compounds would form in the collision, raining down through the gas giant's layers, potentially reaching pressures where they crystallize into forms we've never seen. Diamond rain is already theorized to exist in Jupiter's depths. What would adding interstellar material create? But the latest trajectory analysis suggests something different. Not direct impact. A close pass through Jupiter's upper atmosphere. What scientists call an atmospheric graze. The friction would heat 3IATLAS to thousands of degrees. Its surface would ablate away like a spacecraft's heat shield during re-entry. But if the core is strong enough, if its composition is unusual enough, it might survive. Changed, but intact. That scenario terrifies some researchers, because if 3IATLAS can survive a close encounter with Jupiter, it proves that interstellar objects are more robust than we imagined. More capable of delivering their cargo, whether that's organic molecules, exotic minerals, or something else, deep into solar systems, deep enough to reach habitable zones, deep enough to reach Earth. The November observations will be crucial. As 3IATLAS approaches Jupiter, tidal forces will stress its structure, cracks will form. If it's going to break apart, we'll see the first signs weeks before the closest approach. The Hubble Space Telescope has allocated 40 hours of observation time, an unprecedented amount for a single object. They're looking for fragments, for changes in rotation, for any sign that Jupiter's gravity is winning the battle, but so far, nothing. 3IATLAS maintains its structural integrity despite forces that should be tearing it apart. The latest images show no debris trail, no fragments spinning away, no signs of imminent collapse. It's as if this object was designed to withstand exactly these conditions. Engineered to survive passages through solar systems, built to endure. We need to stop and consider what we're really observing here. Every previous interstellar object detected has been essentially dead. Oumuamua showed no activity. Borisov behaved like a typical comet. They were visitors, but passive ones. 3IATLAS is different. It's active. It's accelerating in ways we can't explain. It's approaching our largest planet with properties that defy our understanding. The scientific community is divided. Conservative voices urge caution, more data, patience. They point out that we've been wrong before, that extraordinary observations often have mundane explanations, that jumping to conclusions about artificial origins or exotic physics usually leads nowhere. They're right to be cautious. Science advances through skepticism, but other voices are asking different questions. What if our instruments are working perfectly? What if the data is accurate? What if 3IATLAS really is accelerating through non-gravitational means that we can't explain with outgassing or radiation pressure? Then we're faced with two possibilities. Either there's a natural phenomenon we've never encountered before, or the alternative is too significant to state casually. Avi Loeb has been the most vocal proponent of considering artificial origins for anomalous interstellar objects. His recent papers outline specific observational tests that could distinguish between natural and artificial objects. 3IATLAS is failing those tests. Its acceleration pattern doesn't match natural outgassing. Its structural integrity exceeds normal cometary materials. Its trajectory seems optimized for gravitational assists, as if it knows where it's going. That's anthropomorphization, of course, applying human concepts to cosmic phenomena. But when the math keeps pointing in impossible directions, when the observations contradict everything we thought we knew, maybe it's time to expand our thinking. Maybe 3IATLAS isn't just testing Jupiter's gravity. Maybe it's testing our assumptions about what travels between the stars. The next 3 weeks will provide answers, or they'll multiply our questions exponentially. Ground-based telescopes are coordinating unprecedented collaborative observations. The European Southern Observatory, Keck Observatory, Gemini Observatory, all synchronizing their schedules to maintain continuous coverage as 3IATLAS approaches Jupiter. They're measuring everything: position, velocity, rotation rate, spectral emissions, magnetic field interactions, building the most complete dataset ever assembled for an interstellar object. Because we might not get another chance like this. Interstellar objects are rare. Ones that interact with planets are rarer still. The odds of witnessing an interstellar object's close encounter with Jupiter in our lifetimes should be essentially zero. Yet, here we are. Either we're extraordinarily lucky, or these events are more common than we thought. Both possibilities reshape our understanding of the solar system's interaction with interstellar space. Current distance from Earth, 0.156 AU, and closing. That puts 3IATLAS closer than Venus at its nearest approach, close enough that space agencies are considering emergency missions. Proposals are circulating for rapid deployment probes that could intercept 3IATLAS after its Jupiter encounter. If it survives, if it's slowed enough by the interaction, we might have a narrow window to send a spacecraft to study it directly, to sample its surface, to determine its composition definitively, to answer the questions that observations alone can't resolve. But those missions require 3IATLAS to behave predictably for the next few weeks, to follow a path we can calculate, and that's exactly what it hasn't been doing. Each course correction, each unexplained acceleration, makes interception more difficult. It's as if the object is actively evading detailed study. Maintaining just enough distance to remain mysterious, the public discourse has become fevered. Opinion polls show 42% of Americans believe 3IATLAS has artificial origins. Science communicators are struggling to balance legitimate scientific uncertainty with the need to prevent panic. Because if this object does collide with Jupiter, the light show will be visible to anyone with binoculars. Millions of people will witness something unprecedented, something that will demand explanation, and we don't have one. Not yet. The latest models from the Planetary Science Institute suggest multiple possible outcomes for December 5th. Scenario 1. 3IATLAS breaks apart before reaching Jupiter, creating a debris field that the planet sweeps up over several months. Scenario 2. It impacts directly, creating an explosion visible from Earth. Scenario 3. It grazes the atmosphere and continues on, fundamentally changed by the encounter. Scenario 4. It misses Jupiter entirely, its trajectory altered at the last moment by forces we don't understand. Each scenario teaches us something different about the universe. But there's a fifth scenario that nobody wants to discuss publicly. What if 3IATLAS doesn't just survive its encounter with Jupiter? What if it uses it? What if the gravity assist is intentional? What if this object is performing a maneuver that our spacecraft perform routinely, but at velocities and with precision that we can't match? That would change everything. It would mean that objects can navigate our solar system deliberately, that the space between stars isn't empty but populated with travellers following routes we're only beginning to detect, that Earth isn't isolated but part of a network of paths that connect star systems across the galaxy. These are massive implications from a single object's trajectory. But 3IATLAS keeps pushing us toward massive implications. The data doesn't lie. Only our interpretations can be wrong. Latest update from the Atlas network. 3IATLAS has begun rotating faster. Not dramatically. Just 2% increase in rotation rate over the past 96 hours. But for an object this size, that represents enormous angular momentum changes. Something is causing it to spin up, solar radiation pressure is too weak, outgassing jets are in the wrong configuration, Jupiter's tidal forces aren't strong enough yet. So what's causing it? We've entered uncharted territory. Every textbook on cometary dynamics assumes certain fundamental principles. Conservation of angular momentum without external torques, predictable responses to heating and cooling, structural limits based on material strength. 3IATLAS challenges all of these assumptions simultaneously. It's not just one anomaly. It's a collection of impossibilities wrapped in a 5-kilometer shell of ice and rock, or something that looks like ice and rock. The spectroscopic data shows familiar compounds on the surface. Water ice, carbon dioxide, methane, ammonia. The same materials we see on comets throughout our solar system, but spectroscopy only reveals surface composition. We don't know what's underneath. We don't know if the familiar exterior hides something unprecedented. We won't know until December 5th, when Jupiter's gravity might crack it open for us to see. Current observation windows are optimal between 9 p.m. and 11 p.m. local time for most of the Northern Hemisphere. Amateur astronomers with 8-inch or larger telescopes can contribute valuable data. Changes in brightness, sudden outbursts, fragmentation events. Any of these could happen without warning. The global community of observers has become an essential part of tracking this object. Professional astronomers can't watch everything. They need help. We all do. Because 3IATLAS represents more than just a scientific curiosity. It's a test of our readiness. If we can't predict the behavior of one interstellar object, how can we prepare for others? They're out there. Statistical models suggest thousands of interstellar objects pass through our solar system every year. Most are too small or too distant to detect. But some, like 3IATLAS, come close enough to matter. Close enough to threaten everything we've built. The Torino scale measures impact hazard risks from 0 to 10. 0 means no hazard. 10 means certain global catastrophe. 3IATLAS can't be rated on this scale because it's not heading for Earth. But if it were, if an object with these characteristics were on an Earth intercept trajectory, we'd be facing a Torino scale 10 event with no viable defense strategy. The speed is too high, the behavior too unpredictable, our current technology insufficient. Jupiter might be showing us our future vulnerability, or our future opportunity. Because if objects can traverse interstellar space at these velocities, if they can survive close encounters with giant planets, if they can carry their cargo across light years intact, then the exchange of material between star systems is far more common than we imagined. Panspermia, the theory that life spreads throughout the universe via space-traveling objects, suddenly seems less like speculation and more like inevitability. 3IATLAS could be carrying the building blocks of life, or life itself. Extremophils, organisms that survive in extreme conditions, have been found in every hostile environment on Earth, inside nuclear reactors, at the bottom of ocean trenches, frozen in Antarctic ice for millions of years. If similar organisms evolved elsewhere, if they were trapped in ice or rock, if that rock was ejected from their home system and travelled through interstellar space, the chain of ifs is long, but 3IATLAS makes it feel shorter. Current brightness magnitude 17.8 and steady. No dramatic changes in the last 48 hours. The object maintains its course toward Jupiter with mechanical precision. Every deviation from gravitational predictions follows patterns that suggest systematic rather than random forces, as if there's a logic to its movements that we haven't decoded, a purpose we haven't recognized. Time to address the uncomfortable truth. Scientists are trained to reject anthropomorphic explanations, to avoid seeing patterns that aren't there, to resist the human tendency to find intention in random events. This training serves us well most of the time. It keeps us grounded in empirical reality. But sometimes, very rarely, the patterns are real. The intention is genuine, and our training becomes a blindfold that prevents us from seeing what's directly in front of us. Is this one of those times? The evidence is mounting. Non-gravitational acceleration confirmed. Structural integrity beyond normal cometary materials confirmed. Trajectory optimized for solar system traversal confirmed. Each piece alone could be explained away. Together they form a pattern that's becoming harder to ignore. Dr. Avi Loeb's latest paper, submitted just yesterday to the Astrophysical Journal Letters, lays out the case mathematically. The probability of natural processes producing all of 3IATLAS's observed characteristics is less than 0.001%. That's not zero. Natural explanations remain possible. But when the odds get that low, when the standard model requires that many coincidences, it's time to consider alternatives. Even if those alternatives challenge everything we believe, the next 72 hours are critical. 3I/ATLAS will cross the orbit of Mars, entering the inner solar system proper. Jupiter's gravity will begin to dominate its trajectory. If fragmentation is going to occur, we'll see the first signs soon. Stress fractures propagating through the nucleus, chunks breaking away, the beginning of the end for this interstellar visitor, or the beginning of something else entirely. Because there's another possibility that nobody's discussing publicly. What if 3I/ATLAS isn't meant to survive the encounter with Jupiter? What if destruction is the point? What if this object is designed to break apart, to scatter its contents throughout Jupiter's atmosphere, to seed the gas giant with materials from another star system? That sounds like science fiction. But so did interstellar objects until we detected one. The implications cascade outward. If objects can be designed to deliver payloads to specific planets, if they can navigate using gravity assists, if they can target worlds with precision across interstellar distances, then the universe is far more connected than we imagined, far more active, far more alive with possibilities we haven't considered. Stop. Let's ground ourselves in what we know for certain. 3I/ATLAS is real. It's approaching Jupiter. It will reach its closest point on December 5th, 2025. These are facts. Everything else, the speculation about origins, the questions about purpose, the possibilities of artificial design, remains hypothesis. But hypothesis is how science advances. We propose explanations, we test them against observations, we refine or reject based on evidence. The evidence keeps pointing in unexpected directions. Latest update from ESA's JUICE mission team. They're adjusting the spacecraft's trajectory to observe the encounter from an optimal angle. This wasn't planned. JUICE was supposed to study Jupiter's moons, not track interstellar objects, but the opportunity is too valuable to miss. To see an interstellar object interact with a gas giant up close, to measure the forces involved, to witness the outcome, this data could revolutionize planetary defense, or reveal that planetary defense is impossible against objects like this. The speed is the key factor. 68 kilometers per second makes conventional intercept strategies useless. By the time we detect an Earth-threatening object moving that fast, it's already too late. No time to launch deflection missions, no time to evacuate impact zones. Just enough time to watch it arrive. 3I/ATLAS is teaching us about our own vulnerability by demonstrating it at Jupiter. But it's also teaching us about possibilities. If objects can survive interstellar journeys at these speeds, if they can navigate through solar systems, if they can withstand encounters with giant planets, then the technology, whether natural or artificial, exists to traverse the galaxy, to connect star systems, to carry information or materials or even life across the cosmic void. We're watching a demonstration of capabilities we don't possess. Current models suggest 3I/ATLAS will lose 10 or 15% of its mass during the Jupiter encounter. The ablation will be visible from Earth as a brightening, possibly even a tail formation. For a few days, this interstellar visitor might look like a traditional comet, but the resemblance will be superficial. The physics underneath will be entirely different. Forces and materials and behaviors that expand our understanding of what's possible. The countdown has begun. 21 days until closest approach. Observatories worldwide are clearing their schedules. Emergency funding has been allocated for additional observations. The scientific community is mobilizing like never before. Because opportunities like this don't come twice. Whatever 3IATLAS is, natural wonder or artificial construct, random visitor or deliberate probe, we need to learn everything we can while it's here. The public deserves to know what we discover. That's why transparency matters now more than ever. The data from December 5th won't be hidden in academic journals. It will stream live to millions of viewers. People will watch as 3IATLAS approaches Jupiter. They'll see the interaction unfold in real time. They'll witness either the violent destruction of an interstellar object or its remarkable survival. Either outcome will be historic. Both outcomes will raise questions we're not prepared to answer. What does it mean if 3IATLAS survives? It means our understanding of material science needs revision. Our models of planetary encounters need updating. Our assumptions about what can traverse interstellar space need expanding. It means the universe is more robust, more capable of connections across vast distances than we imagined. What does it mean if it's destroyed? It means Jupiter continues to serve as our solar system's guardian, sweeping up dangerous objects before they can reach the inner planets. It means the forces that protect Earth from cosmic threats are stronger than even this remarkable object. It means we're safer than we thought, at least from this particular type of visitor. But safety and knowledge aren't the same thing. The real value of 3IATLAS isn't in the threat it poses or doesn't pose, it's in the questions it forces us to ask. About our models, about our assumptions, about our place in a universe that's clearly more dynamic than we understood. Every anomaly in its behavior, every deviation from predictions, expands our awareness of what's possible, and possibly what's watching. Because objects don't achieve these characteristics by chance. The combination of properties that 3IATLAS displays, the speed, the structural integrity, the non-gravitational acceleration, the precise trajectory, suggests optimization, design, purpose. Whether that design is natural or artificial remains unknown. But design implies a designer. Purpose implies intention. These are dangerous thoughts for scientists trained in materialism, but science has always advanced by thinking dangerous thoughts, by challenging orthodoxy, by following evidence even when it leads to uncomfortable conclusions. 3IATLAS is leading us somewhere new, somewhere that requires us to expand our framework for understanding objects that move between stars. The latest spectroscopic analysis reveals something subtle but significant. The isotope ratios in the gases escaping from 3IATLAS don't match any solar system object. The deuterium levels are wrong. The carbon-13 abundance is off. These are fingerprints of formation in a different stellar environment. Proof that this object truly comes from elsewhere. From a star with different characteristics, a system with different history, a place that might still be watching their emissary's journey. That's speculation, of course. We have no evidence of observation from elsewhere, no signals, no messages, just this object, moving through our solar system with characteristics we can't explain, approaching an encounter that will either destroy it or transform it, while we watch with every instrument we possess. The parallel is impossible to ignore. We send probes to study other worlds, Voyager, Pioneer, New Horizons, all carrying messages from Earth as they head into interstellar space. If we do this, if we send representatives to study and explore and eventually escape our solar system, why wouldn't others? Why wouldn't other civilizations, if they exist, send their own emissaries, their own observers, their own messages in bottles thrown into the cosmic ocean? 3IATLAS might be one of those bottles, or it might be a completely natural phenomenon that we simply don't understand yet. The universe is vast and strange. It produces structures and behaviors that challenge our Earth-based intuitions, pulsars that spin hundreds of times per second, black holes that bend space-time, dark matter that we can't see but know exists. 3IATLAS might be another entry in the catalogue of cosmic mysteries that eventually yield to scientific understanding. But something feels different this time. Maybe it's the timing, the way 3IATLAS appeared just as our detection capabilities reached the point where we could track it. The way its trajectory brings it close enough to study, but not close enough to threaten Earth directly. The way it demonstrates advanced capabilities while remaining just mysterious enough to avoid definitive classification. It's as if this object was designed to teach us something, to prepare us for what's coming next. because 3I-ATLAS won't be the last interstellar visitor. Our detection systems are improving, our surveys are becoming more comprehensive. We're going to find more objects from beyond our solar system. Some will be like Oumuamua and Borisov, relatively simple, following predictable paths. Others might be like 3I-ATLAS, complex, anomalous, challenging our understanding. And eventually we might find one heading directly for Earth. That's why December 5th matters so much. Jupiter's encounter with 3I-ATLAS is a test run for Earth's future encounters with interstellar objects. We're learning what works and what doesn't, what we can predict and what surprises us, what threatens us, and what might benefit us. Every measurement, every observation, every model refinement makes us better prepared for the next visitor, the one we might not see coming until it's too late. Current observational status: 3I-ATLAS remains visible in the constellation Virgo, moving against the background stars at a rate that amateur astronomers can detect over successive nights. Its apparent magnitude holds steady, suggesting no major structural changes yet. But that will change as Jupiter's gravity takes hold. The object that has travelled for perhaps millions of years through interstellar space is about to experience forces unlike anything in the void between stars. We're about to witness cosmic violence on an unprecedented scale, or cosmic engineering of unprecedented sophistication. Because if 3I-ATLAS survives its encounter with Jupiter, if it uses the gas giant's gravity to accelerate even further, if it exits our solar system faster than it entered, then we're not watching random cosmic pinball. We're watching navigation, deliberate use of our solar system's largest planet as a gravitational slingshot, a maneuver our spacecraft perform, executed by an object from another star. The philosophical implications demand consideration. For centuries we've wondered if we're alone in the universe. We've searched for radio signals, looked for megastructures, analysed atmospheres of distant planets. But what if the evidence has been passing through our solar system all along? What if objects like 3I-ATLAS are the messages we've been waiting for? Not radio waves or laser pulses, but physical artifacts carrying information across interstellar distances. It would be the most profound discovery in human history, and it would happen at Jupiter on December 5th, 2025. But even if 3I-ATLAS proves to be natural, even if every anomaly has a conventional explanation we haven't thought of yet, its passage changes us. It reminds us that our solar system isn't isolated, that objects from other stars visit regularly, that the space between worlds isn't empty but filled with travellers we're only beginning to detect. Each one carries secrets about where it formed, what forces shaped it, what it's made of, how long it's been travelling, where it's going next. These are stories written in ice and rock and strange trajectories, stories that connect our small solar system to the vast galaxy beyond, stories that we're just learning how to read. 3I-ATLAS is teaching us the language. Every anomaly is a vocabulary lesson, every unexpected behaviour is a new grammatical rule. The non-gravitational acceleration tells us about propulsion mechanisms we haven't discovered. The structural integrity reveals materials science we haven't achieved. The trajectory optimization shows navigation techniques we haven't imagined. We're students watching a masterclass in interstellar travel. Whether the teacher knows we're watching remains unknown. As we approach the final weeks before encounter, the scientific community has divided into camps. The conservatives maintain that natural explanations will emerge, that patient observation and careful analysis will reveal 3I-ATLAS to be an unusual but ultimately comprehensible natural object. They point to history. How many times apparent anomalies resolved into known phenomena once we had better data? The progressives argue that 3I-ATLAS has already broken too many rules, that continuing to force natural explanations onto clearly anomalous behaviour is dogma, not science. They call for expanded hypotheses, including the possibility of artificial origins. They remind us that discovering we're not alone would be the most important scientific finding ever made. Both camps agree on one thing: December 5th will provide answers. The encounter will strip away speculation and leave us with facts. Either 3I-ATLAS behaves like a natural object under extreme stress, fragmenting and dispersing according to known physics, or it doesn't. Either its trajectory through Jupiter's gravity well follows our models, or it doesn't. Either it emerges from the encounter as debris, or it continues on, changed but intact, carrying its mysteries deeper into space. The universe is about to show us something extraordinary. The question is whether we're ready to see it. As we enter this final phase of observation, as 3I-ATLAS accelerates toward its date with Jupiter, we find ourselves at a unique moment in scientific history. We have the tools to watch, the knowledge to understand, the wisdom to ask the right questions, but most importantly, we have the humility to admit that we might be wrong about fundamental aspects of our cosmic neighborhood. That humility is science's greatest strength, the willingness to let evidence override ideology, to let observations reshape theories, to let a 5-kilometer chunk of ice and rock teach us about the universe. 3I-ATLAS is a harsh teacher, presenting lessons whether we're prepared or not, forcing us to confront the limitations of our models, making us question assumptions we didn't know we held. But the best teachers always do that. They show us not just what we don't know, but what we didn't know we didn't know. They reveal depths to subjects we thought we'd mastered. They humble us with our ignorance while inspiring us to learn more. 3IATLAS is doing all of this, compressed into a few months of observation that will echo through scientific literature for decades. Future textbooks will have a chapter on 3I-ATLAS. What that chapter says depends on what happens at Jupiter. Will it describe the first confirmed artificial object from another star system? Will it explain new physics discovered through anomalous acceleration? Will it detail the violent destruction that proved our models right after all? Or will it record something we can't yet imagine? Something that emerges from the data we're about to collect? 21 days to find out. The countdown focuses our attention like nothing else could. Every hour matters now. Every observation could be the one that solves the mystery or deepens it. Professional astronomers are pulling all-nighters. Amateur observers are setting alarms for optimal viewing windows. The entire planet is turning its eyes toward a dim speck of light approaching the king of planets. Because deep down, we all understand what this means. 3I-ATLAS isn't just about one object. It's about our future, about the kinds of visitors we can expect, about the threats we need to prepare for, about the opportunities we might embrace. It's showing us that the universe is more active, more interconnected, more alive with possibilities than we dared imagine, and possibly more inhabited. That's the thought that keeps scientists awake at night. Not fear, but wonder. The possibility that 3I-ATLAS represents contact, even if indirect, even if unintentional, even if the builders never imagined their creation would be scrutinized by telescopes on a small blue planet orbiting an ordinary yellow star. Or maybe they did imagine it. Maybe that's exactly what they hoped for. The human impulse to find meaning in cosmic events is strong. We see faces in clouds, patterns in randomness, intention in chaos. Usually this impulse misleads us, but sometimes, rarely, it reveals truths our rational minds resist. Sometimes the pattern is real, the intention genuine, the meaning actually there, waiting to be discovered. Is 3I-ATLAS one of those times? We'll know soon. As December 5th approaches, as Jupiter looms larger in 3I-ATLAS's path, as our instruments focus with unprecedented precision, we stand at a threshold. On one side, the universe, as we've understood it, vast, mostly empty, occasionally violent but ultimately random. On the other side, a universe with purpose, with engineering, with intelligence moving between the stars. Both universes are profound. Both are terrifying, both are wonderful. The beauty of science is that we don't get to choose which universe we live in. The evidence decides, the data speaks, the observations reveal truth regardless of our preferences. And 3I-ATLAS is about to provide evidence that could fundamentally alter our understanding of our place in the cosmos. That's why every telescope on Earth will be watching, why every space agency has cleared their schedule, why millions of people will stay up late on December 5th, watching live streams of an event 600 million kilometers away. We're not just observing an astronomical phenomenon, we're potentially witnessing first contact, or at least first evidence, first proof that we're not alone in creating objects that travel between stars. But even if we are alone, even if 3I-ATLAS proves to be entirely natural, its journey teaches us something essential. The universe builds bridges between stars. Whether through random chance or deliberate design, objects carry materials and perhaps information across the light years. Our solar system isn't an island but part of an archipelago, connected by travellers we're only now learning to see. Each interstellar object that passes through is a thread in a vast cosmic web. 3IATLAS is showing us how strong those threads can be, how fast they can carry their cargo, how precisely they can navigate using gravity and forces we don't fully understand. The web exists whether we see it or not, but seeing it changes everything. It changes how we think about planetary defense, about the origins of life, about our future as a species that might one day send our own emissaries to other stars. 3IATLAS is showing us what's possible, what survives the journey, what techniques work for crossing interstellar space. We're learning by watching, even if we don't fully understand what we're seeing. The final approach has begun. Each day brings 3IATLAS millions of kilometers closer to Jupiter. The gas giant's gravity reaches out, invisible but inexorable, bending the visitor's path. What started as a straight line through interstellar space is becoming a curve, a parabola, a trajectory that will either embrace Jupiter or slingshot around it. The mathematics are beautiful in their simplicity. Force equals mass times acceleration. Every action has an equal and opposite reaction. The conservation of energy and momentum, these laws discovered on Earth, apparently apply to objects from other stars. That universality itself is profound. It means the universe operates by consistent rules, rules we can learn, rules we can use, unless 3IATLAS breaks them, which it might. The non-gravitational acceleration remains unexplained. The structural integrity exceeds predictions. The trajectory optimization suggests capabilities we haven't achieved. If these anomalies persist through the Jupiter encounter, if they intensify under stress, if they reveal new physics or new technologies, then our understanding of those universal rules needs expansion. Science thrives on such challenges. Every anomaly is an opportunity. Every mystery is an invitation to learn more. 3IATLAS has issued that invitation in the most dramatic way possible, by demonstrating capabilities while approaching our solar system's largest planet at impossible speeds. We couldn't ignore it if we tried. And why would we want to? This is what we live for. The moment when the universe surprises us, when our models break and need rebuilding, when a chunk of ice and rock from another star teaches us that we've been thinking too small, that the cosmos is stranger, more wonderful, more alive with possibilities than we dared imagine. That's the real gift of 3IATLAS, regardless of its origins or fate. It's expanding our conception of what moves between the stars, what survives the journey, what finds its way from one system to another across distances that dwarf human comprehension. Every civilization that looks up at the night sky eventually wonders if they're alone. 3IATLAS isn't answering that question directly, but it's showing us that the infrastructure for connection exists. The pathways are there. Objects do make the crossing. Whether intelligence guides them remains to be seen, but intelligence is definitely watching them. Our intelligence. Human curiosity focused through telescopes and computers, and brilliant minds struggling to understand. We're proving that at least one planet in the universe cares about these interstellar wanderers, tracks them, studies them, learns from them. That itself is profound. It means the universe has developed the capacity to observe itself, to wonder about its own mechanisms, to search for meaning in the motion of objects between stars. We are the universe looking at itself. And through 3IATLAS, we're seeing something new. As the countdown continues, as December 5th draws closer, as Jupiter prepares to meet its interstellar visitor, we find ourselves united in curiosity. Political divisions, cultural differences, personal conflicts, all fade against the magnitude of what we're about to witness. For a moment, humanity remembers that we're all on the same small planet, watching the same cosmic drama unfold. That unity might be another gift from 3IATLAS, a reminder that our differences are trivial compared to the vast unknown that surrounds us, that the real frontier isn't between nations but between known and unknown, between understood and mysterious, between the solar system we inhabit and the galaxy we're just beginning to explore. 3IATLAS is our guide into that galaxy, our first detailed look at what traverses the spaces between stars, our teacher in the mechanics of interstellar travel. Whether it survives Jupiter or not, whether it's natural or artificial, whether it carries meaning or just mass, it's already changed us. Changed how we think about our cosmic neighborhood, changed what we watch for in the night sky, changed our sense of isolation or connection with the universe beyond. The final phase begins now. Telescopes around the world and in space are locked onto 3IATLAS's position. Computers are processing terabytes of data in real time. Scientists are refining models, adjusting predictions, preparing for surprises. The entire scientific community is holding its breath, waiting to see what the universe is about to teach us, because that's what this is really about. Not just one object, not just one encounter, but our ongoing education in the true nature of the cosmos. Every anomaly is a lesson. Every mystery is curriculum. Every unexpected observation is the universe saying, "You thought you understood, but there's more. There's always more." And we're eager students, ready to learn. On December 5th, 2025, at approximately 14:00 UTC, 3IATLAS will reach its closest approach to Jupiter. The exact distance remains uncertain. Our models have error bars that grow with each anomalous observation. It could pass within the Roche limit and be torn apart. It could graze the atmosphere and emerge transformed. It could miss entirely, its trajectory altered at the last moment by forces we don't understand. Each outcome teaches us something different, about the robustness of interstellar objects, about the power of planetary gravity, about our ability to predict cosmic events, about the range of possibilities the universe permits. We're about to receive a lesson we didn't ask for but desperately need. Because more visitors are coming. Statistical models guarantee it. Objects from other stars will continue passing through our solar system. Some we'll detect, others will slip by unseen. Each one carries information about its origin, about the conditions that created it, about the forces that launched it on its interstellar journey, about the galaxy we inhabit but barely understand. 3IATLAS is preparing us for those future encounters, teaching us what to watch for, what to measure, what questions to ask, how to distinguish natural from artificial, how to track objects moving at extreme velocities, how to predict behaviors that don't match our models. These are survival skills for a species that's just discovering it lives in a cosmic shooting gallery. But also skills for a species that might one day join the interstellar travelers. Because if objects like 3IATLAS can make the journey, so can we. Not biological humans, the distances are too vast, the journey too long, but our machines, our probes, our messages encoded in silicon and metal, launched toward other stars just as 3IATLAS was launched toward ours. We're watching our future, or our past, or both. The possibility that 3IATLAS is artificial can't be dismissed. The evidence doesn't prove it, but it doesn't disprove it either. And that ambiguity itself is significant. It means we've reached a point where natural and artificial objects might be indistinguishable at distance, where the universe has potentially evolved multiple ways of creating interstellar travelers, where intelligence might hide in plain sight, camouflaged as natural phenomena. That's a threshold we've never crossed before. The moment when we have to seriously consider that some fraction of what we observe in space might be engineered. Not all of it, probably very little of it, but some. Enough that we need protocols for identification, criteria for classification, plans for what to do if we confirm artificial origin. 3IATLAS is forcing us to develop those protocols now under pressure, with December 5th as our deadline. The scientific community is rising to the challenge. Papers are being written, peer-reviewed, and published at unprecedented speed. International collaborations are forming overnight. Data is being shared openly, without the usual institutional barriers, because everyone understands that this is bigger than individual careers or national prestige. This is about humanity's understanding of its place in the universe, and that understanding is about to change dramatically, whether 3IATLAS survives Jupiter or not, whether it's natural or artificial, whether it carries meaning or just momentum. The simple fact that it exists, that it's here, that it's demonstrating these capabilities, expands our awareness of what's possible. The universe is revealing itself to be more dynamic, more interconnected, more alive with motion and possibility than we knew. Every previous generation has had to expand their conception of the cosmos, from Earth-centered to Sun-centered, from one galaxy to billions, from static to expanding, from empty to filled with dark matter and dark energy. Each expansion was traumatic, forcing humans to reimagine their place in an ever larger, ever stranger universe. 3IATLAS represents our generation's expansion, The realization that interstellar space isn't a barrier but a highway, that objects routinely travel between stars, that our solar system is constantly receiving visitors from elsewhere. That isolation is an illusion created by our limited detection capabilities, not a fundamental truth about our position in the cosmos. As we count down these final days, as Jupiter looms ever larger in 3IATLAS's future, as our instruments gather data that will be analysed for decades, we stand at a turning point, not just in astronomy or planetary science, but in human consciousness, in our understanding of what kind of universe we inhabit. Is it a universe where we're alone, surrounded by natural phenomena that occasionally mimic intention? Or is it a universe where intelligence is common, where artifacts traverse the void, where we're late to discover a galaxy already busy with interstellar traffic? December 5th won't definitively answer that question, but it will provide evidence, strong evidence, the kind that shifts scientific consensus and public perception, the kind that changes everything. This is what we've been waiting for without knowing we were waiting, the moment when speculation becomes observation, when possibility becomes probability, when the universe stops being theoretical and becomes viscerally, undeniably real. 3IATLAS is making the cosmos tangible, turning abstract concepts like interstellar object into specific things with measurable properties and dramatic destinies. In 21 days, Jupiter will test those properties, stress them beyond anything they've experienced in interstellar space, either break them or prove them stronger than we imagined. The violence of that test will be visible from Earth, a reminder that the cosmos isn't just beautiful but dangerous, that survival requires more than we currently possess. That evolution, biological or technological, never stops. But within that violence lies opportunity, the chance to learn, to grow, to expand our capabilities based on what we observe. Every spacecraft we've ever sent to Jupiter has taught us something new. 3IATLAS might teach us more in one encounter than all previous missions combined. Not about Jupiter, but about what's possible, about what survives, about what travels between the stars. The countdown continues. December 5th approaches. Jupiter waits, and we watch, knowing that we're about to witness something that will be remembered as long as humans exist. The day an interstellar object met the king of planets. The day our models either broke completely or proved more robust than we dared hope. The day the universe revealed another of its secrets, or deepened its mysteries even further. Because that's possible too. Atlas might behave in ways that don't just challenge our current understanding, but reveal how much we still don't know, how many forces we haven't discovered, how many phenomena we haven't imagined, how vast our ignorance remains despite centuries of scientific progress. That would be humbling, but also exhilarating, because it would mean the universe still has surprises for us, still has lessons to teach, still has wonders we haven't dreamed of. 3IATLAS might be showing us not how much we've learned, but how much more there is to learn, how many more mysteries await, how many more impossible objects will force us to rewrite our textbooks. This is why we do science, not for the answers, but for the questions, not for the certainty, but for the wonder, not for the known, but for the vast unknown that calls to us across the light years. 3IATLAS is that call made manifest, a physical embodiment of everything we don't yet understand about the cosmos. And in 21 days, when it meets Jupiter, we'll understand a little more, or realize we understand even less than we thought. Either outcome advances science, either outcome expands human consciousness, either outcome brings us closer to comprehending our true situation in a universe that's clearly more complex than we imagined. The final countdown has begun. History is about to be made, and we have front row seats to watch the universe reveal its next secret, or its next mystery, or both. December 5th, 2025. Remember that date. It's when everything changes.